like to show you briefly how we are doing a cable correction with our system. And this is a different lab, so we have a slightly different setup, but the programming and the way of doing it, it's exactly the same. Here we've got the Programmable Josephson array. It's now just showing the cryoprobe with any synthesizer, but it's connected to the bias source here. And then it's going here via a switch to the PXI, and this is the generator we want to measure. For the cable correction, we have to consider that we can bring together the digitizer very close to the generator, but the Josephson will be always down in the liquid helium, so far away from these two instruments. And this long cable makes an error which we have to correct for. So the idea of this method is to use the calibrator, to use the ADC or the digitizer to measure the generator on a short distance by using the switch in between and putting a short on this output channel as a switch. So the signal goes via the switch directly to the digitizer with a short cable. If we switch to the other position, as we see now with the green light, we go all the way down to the Josephson array and then back to the digitizer. By setting a specific frequency with an amplitude of 1 volt or whatever we like to investigate, we can see the difference when switching from the two positions of the switch. We can see the short cable in relation to the long cable to the Josephson system. And we have also to consider that the Josephson system is not just an isolated system, it's connected to a bias source which also gives a capacitance to the earth. So there's another pass through the earth also to this digitizer. So if we do this kind of measurement, we can see that at low frequencies the difference between the two measurements is very small, because at low frequencies cable correction doesn't play a role. But if we go to higher frequencies up to 100 kilohertz, we see this quadratic increase. That's something we expect because the cable correction is going with a square of frequency. In both cases we are using the digitizer, so we do not expect any systematic errors from the digitizer because it's just measuring the two ways of the different of the cable length. I can show you now this program. I just have to switch on here. And within the program, you sweep in specific frequencies, or as we do here now, we just put the frequencies in a table which we want to investigate. And I should clear this graph. What you see now is, so the digitizer is reading. You can see on these lamps going on and out, and the switch is switching from one position. Now it's connected to the Josephson, and then it's switching back. It's taking reading, then it's switching back, taking readings, and just the differences are displayed in this diagram. Just one measurement has finished. We are covering now the frequency range from 1 kilohertz up to 125 kilohertz. And what is plotted is the difference between the two cable lengths we are measuring here. So as we assume the cable length with the short is almost within ppm level, we directly can see the uncertainty which is introduced by the long cable length. So every frequency we put here into this measurement routine takes about 1 minute. So for this 25 20 frequencies. It only takes 20 minutes, and usually we do this before doing subsampling measurements and afterwards, that we have the data and the cable correction for the system as it is in that moment, with the same helium level and so on. Questions?